Well, welcome to our lesson on properties of exponents. Some of this may be a little bit of review. I know we've covered and talked about exponents already this year, so this one should go fairly quickly for you. We'll be learning how to simplify exponential expressions and also using scientific notation to solve word problems. So first of all, our exponent rules, I've got those summarized for you here on this page. If we have a power to a power, so any number raised to an exponent and then that whole term raised to another exponent, we multiply those two exponents. And similar to that is the power of a product. So if we have a product of two numbers raised to a power, then that means everything inside the parentheses gets raised to that same power. And the power of a quotient rule is very similar to the power of a product rule. Anything in the parenthesis gets raised to the power on the outside. And when we have a negative exponent here, what that does, we have two options with a negative exponent. We can raise each thing inside to the negative exponent, or we can flip the numerator and denominator and raise it to the positive exponent. So most often we'll use this one. We'll flip the numerator and denominator and then write it to the positive exponent. And the zero power, anything to the zero power, is equal to 1. So when it says simplify in your directions, what they mean by that is that you have to get rid of all of your parentheses and you're not allowed to have any negative exponents in your answers. So let's go ahead and get started on some examples. So this says simplify the expression, so we want to get rid of all of our parentheses and any negative exponents. And so what we're going to do is we're going to multiply the number parts. 3 times a negative 4 gives us a negative 12. And then we're going to have an x term and a y term. And we have x to the third and x to the second, and we're going to add those, giving us x to the fifth. And then we have y to the second, y to the fourth, giving us y to the sixth. So you can rearrange and reorder any of those as long as there's no addition or subtraction in there. Example B, we have a to the minus 3 times a to the second. So again, we're going to add those together. So negative 3 plus 2 is a negative 1. B to the fourth and c to the minus 1. But we can't have any negative exponents in our answers. So we'll end up with b to the fourth in the numerator, and then a and c both go down to the denominator, making those positive exponents. So I've given you a couple of problems to try here for letter C and D and bring those answers to class. Another example here where we have the quotient property. Remember, the quotient property said that we subtract the exponent, so we're going to have p to the 3 minus 8. And that'll give us p to the minus 5. So no negative exponent, so that's 1 over p to the 5 power. Again, here's a couple more for you to try. I'm just going to zip through these and we can talk about those in class. 2 more examples here. Power to a power, we multiply, so it's a to the 3 times 6, which is 18. Over on the right-hand side for letter B, everything in that parenthesis, 3x gets raised to the fourth, and then y gets raised to the fourth. So the thing to be careful of here is the negative 3 also gets raised to the fourth power. So negative 3 to the fourth power, x to the fourth, all over y to the fourth. And the only thing we have left to do is figure out what negative 3 to the fourth power is, and that is a positive 81, x to the fourth, over y to the fourth. So our parentheses are gone and we have no negative exponents. Don't forget to do the two that are your turn. All right, this example we have a fraction and everything is raised to the fourth power. So I'm going to go ahead and write that out. Negative 2 raised to the fourth power. And then I have x to the 3n raised to the fourth power, all over x to the 2n, again raised to the fourth power, and y to the third raised to the fourth power. Okay, so negative 2 raised to the 4th power gives me a positive 16. In the numerator, I'm going to get x to the, we're going to multiply these, x to the 12n. In the denominator, I'm going to get x to the, looks like 8n, and then y to the 12. And we have one more thing we need to do. These x terms, we can subtract those exponents. So we're going to have 16 x to the 12n minus 8n. I'll just write that one out for this time. 12n minus 8n all over y to the 12. Well, x to the 12n minus 8n, that's x to the 4n, and then it's all over y to the 12th. So that is our final answer. A couple more for you to try on your own. And then scientific notation. I know this is a review for you. I know we've talked about this. A number is in scientific notation when it's in the form given here, where you have a number times a power of 10. This number has to be between 1 and 10. It has to be bigger than 1 but less than 10. And n has to be an integer, meaning a positive or negative whole number. And a lot of the problems that we encounter in the real world will use what we call dimensional analysis, which is a specific way to apply scientific notation. So here's a word problem for you. It says after the Sun, the next closest star to Earth is Alpha Centauri c, and it tells us its distance away. We want to know how long does it take light from that next closest star to reach the Earth. So you're going to be using the speed of light, which is 3 times 10 to the 8th meters per second. And we're going to use the formula distance is rate times time. And I went ahead and solved that for time because we are looking for time, how long. So we want to know how much time it takes for this to happen. So the distance was given as 4 times 10 to the 16th meters. And we're going to divide that by the rate, which is the speed of light. And then we can divide these two numbers. We can split this up into two different things. 4 divided by 3, and then 10 to the 16th divided by 10 to the 8th. And that gives us about 1.33 times 10 to the 8th seconds. Now if we convert that number of seconds into a unit that's more meaningful to us, that ends up being 4.2 years, which is a pretty long time. That's it for this video. We'll see you next time.